Hello everybody, welcome to this presentation about using GIS data to create Flight Simulator Autogen. I originally gave this presentation at the Flight Simulator conference in Paderborn in Germany last month. And this is another recording I'm making of this presentation so that those of you who haven't been at the conference can also watch it. So as the title already mentions, in this presentation I'm going to talk about how GIS data can be used to create Autogen for Flight Simulator. And don't worry if you don't know what GIS data is or what Autogen exactly is, because that's what I will cover first in this presentation. So I'll first explain what Autogen is and how it works, a bit from a developer point of view. Then I will talk about GIS data, what it is and what you can do with it. And in the last part of this presentation I will combine those two elements and show you how to use GIS data to create Autogen. So let's get started. What is Autogen scenery? As the name already sort of implies, it's automatically generated scenery, and that means that it's scenery that is not completely hand modeled by the developer of the scenery, but at least partly generated by the rendering engine of Flight Simulator. And what I mean with hand modeled is somebody in a 3D modeling tool like 3D Studio Max or Gmax is really creating the building. He's designing all the textures, completely making the building. That's not how Autogen works. Autogen is, for example, a house that is generated by Flight Simulator based on a rectangle that defines the location of that house. But we'll come more to the details of how it works later on. An important restriction of Autogen is that it can only be used on land class textures or on photo scenery. So if there's no photo scenery as part of your scenery and there's no land class texture as well, you can't just place an Autogen house or an Autogen tree at a certain place. You need one of those two elements there. And in this presentation I'm mainly going to focus on Autogen for photo scenery, because that's where the power of GIS data is best used. So I will not talk much about land class textures from now on. So what kinds of Autogen scenery are there available? The picture you see here, all the objects are Autogen. It's a piece of default scenery somewhere in Germany. And all the houses and trees and objects that you see here are Autogen objects. So for example, there's those vegetation, you see trees everywhere. They're created by the rendering engine. The houses are Autogen objects, they're created based on rectangular footprints. The water tower you see in the middle is also an Autogen object. It's a library object placed through the Autogen system. And at the back you might just be able to see it. There's a row house, which is another kind of Autogen object, but you see it placed in this village as well. So that's roughly the different type of Autogen objects there are. And in a few slides I will give you a little bit more detail about what kind of parameters you can set on these objects from a developer point of view. So for example, which things can you influence when placing Autogen objects. But before I go to that, there's one other thing I need to mention, and that's how the Autogen files are organized. You've probably seen scenery that uses Autogen before. If you look in the texture folder of that scenery, you'll see a lot of files with the AGN extension. And as a file name they have very weird names with a lot of numbers in them. That might look weird, as I said, but actually those numbers exactly define where on the earth that piece of Autogen should be placed. So the file name determines the location of the objects. And each file covers an area of roughly 1.2 by 1.2 kilometers. And in the sort of the way the train engine of Flight Simulator works, that's called a LOD13 tile. So for each area of roughly 1.2 by 1.2 kilometers, there's one file in which you can define which houses, which trees and which other objects should be placed. And if you want to cover a big area, like many thousand square kilometers, you can imagine you get a lot of Autogen files. And why do I mention those files? Those tiles, they have an influence on what you can do, because there are a number of settings that you can only set per tile. So that means for that area of 1 by 1 kilometer, certain settings are the same. So for example, the height of the buildings is defined for that square kilometer area. So for that area you can say I want to have a lot of tall buildings because this is a city center, or I want to have mainly short buildings because it's kind of a residential suburban area. But that can only be defined for areas of 1 by 1 kilometer. So you don't have finer control over those settings. The same goes for the texture that is used for the buildings. That's also defined per tile. And in the FS 2004 style Autogen, the same applied to tree types as well, vegetation types. But in FSX we have more control over that, as you'll see later on. So that's something to keep in mind when thinking about what you can do with Autogen. Now let's have another look at the different types of Autogen that are available. One of the most often used types of Autogen is probably the Autogen house, as you saw in the screenshot before. And those buildings are always rectangular in shape, so that's an important limitation of them. They need to be rectangular in shape. You can choose what kind of roof type they will get, so you can choose if it's a flat roof, if it's a peaked roof, if it has a gable or not, if it has a wall around the roof, etc. There are a number of different types of roofs available, and as I mentioned before, the height and the texture used by the building are determined per Autogen tile. Here the picture on the side that you see is the typical kind of texture that is used for the Autogen buildings, and you can replace this texture sheet for your specific scenery. So that way you can change how the houses look. Maybe some countries have more red roofs, other countries have more dark roofs, or houses with lighter color or darker color. So by changing this texture you can get a better look and feel for the region you are making. Then the next type of Autogen is vegetation, which comes in two types. One is rectangular vegetation. So then the area that will be filled with trees has to be rectangular in shape. In Flight Simulator 2004 that was the only type of vegetation. But in FSX we can also have polygonal vegetation, which means you can just draw a polygon of any shape that you want, which gives you a lot more flexibility. And for the vegetation you can choose what kind of tree it should be. The picture you see here on the side is just a small section of the list of tree types that is available by default in Flight Simulator X already. So you see there's quite a lot of choice of different kinds of trees, and there are also groupings that mix those trees in a realistic way. Then another kind of Autogen object are library objects. We saw the water tower in the picture before already. For those objects you basically choose an object class, and that will determine the object you get. It's important to remember here that it's an object class, and an object class can contain different objects. So for example there are default classes that contain like commercial buildings, and then you might get either a fast food restaurant or a gas station or like a small shop. So the Autogen system randomly chooses between the different objects that are defined in the class and then places one of them in your scenery. So that way you can have a bit of randomness in there as well. But all of these objects in one class will typically have the same size. So they all cover roughly the same area when placed in the scenery. Then another type of Autogen object that's available is a polygonal building, which is new in Flight Simulator X. So that means that the footprint of your building doesn't have to be rectangular anymore, but it can be any shape basically. And you can still choose like what kind of roof type you want. It's usually a combination with how many floors and type of roof. That's what you choose. But the main downside of this kind of building is that you always have to extrude them around the footprint outline that you draw, which means that you get the kind of courtyard in the middle as you see on this picture here. And for some buildings that's very useful, but in a practical scenery, at least the kind of European sceneries I usually work on, I find them not so useful. And the height and texture used are linked to the roof type for this kind of buildings. And then the last Autogen type available is the Autogen row house that we saw on the picture in the beginning already. And for those, basically everything is fixed. You can't choose the amount of floors, you can't choose the texture. You can choose the texture used, but that's all you can choose. And I don't think they're used that much by scenery designers, so I will not focus on that type from now on. So that gives you an idea of different kind of Autogen objects that are available. And then probably the next question you have is, how can I add this kind of Autogen to my scenery? The SDK that comes with Flight Simulator comes with a tool which is called the Annotator tool, and that's the default way to create Autogen for a land class texture or for a photo scenery. So this way you can annotate the texture as they call it, and then place the Autogen objects on it. And to give you an idea how it works, I'll just illustrate it. So I'm going to jump to Annotator, and here I've loaded a piece of photo scenery. It's from an island in the Netherlands, the island Schiermonnikoog, and this is from the Netherlands 2000 scenery. And I'll just use this as an example to show you how it works to annotate a texture. So I'm zooming in a bit onto the photo now, and then we will going to place some vegetation, some houses, and some library objects. And let me zoom in a little bit more. And it's basically a manual process. I would have to manually define where the different houses are. Okay. So for example, I will click on I want the building first, and then like I do here, I would just trace the side of the building and then define how long it should be, and that is repeated for every building. And I guess you understand now how it works, so I'll stop showing how buildings work. For vegetation, I could, for example, trace this vegetation area here with polygonal vegetation, because it's quite irregular in shape. So then I just roughly draw around the shape, and I say close the object, and then I have a polygon, and this area will be filled with trees. And I can repeat that for example, this area here as well. And I can also repeat that. Like I said, there's also rectangular vegetation, which is more like this. It's always a rectangle, and I can just, I can still cover the trees with it, so that Flight Simulator will populate it with trees. But I think the polygonal vegetation is much more powerful in general. Then to illustrate how the library object works, I'll just pick an urban street light, and I'll say library object, and I can then define those lights here along my road, for example, and each of those blue boxes you see here will become a library object. So I guess you'll see the basic workflow of creating Autogen now. I guess you also see that it can be quite labor intensive. I mean, this is a relatively small island, so probably if I would just concentrate on it in a few hours, I could place almost all of the houses and all of the trees here on the island. But it's a bit boring work, and if you want to cover a much bigger area than such a relatively small island, you'll see that it's a lot of work, almost too much work. But what I'll be talking about in the remainder of this presentation to show you how that can be done easier. There's one small side step I want to do. I talked about the polygonal Autogen buildings before, and I mentioned they always need to have a courtyard. Let me just illustrate what I meant there. So now I select polygonal building, and I can just create almost any outline that I want, and then I define the width of the building. It can be both directions basically. But you see there's always the courtyard in the middle, the open area in the middle, because every part of the sort of the outline gets the same width. And I can't, you see it turns red now, have it completely filled up, because then different walls will be intersecting with each other and the scenery engine can't draw the building anymore. So I could create something like this. There might be cases where it's very useful in your scenery, but I think it's only a few of them normally. Okay, so that's how you are supposed to create Autogen if you look at the SDK. But as you can see, it's quite labor intensive. So let's see if we can do anything about that. And yeah, to see how and if we can use GIS data for that, I will first want to give you an introduction on GIS data. So what is GIS data? GIS stands for Geographic Information System, and then GIS data is data that is worked with on a geographic information system. That's the basic definition. A quite general and broad definition can be that GIS data is any data that is somehow linked with a geographical location. So it's a piece of data that is somehow linked to a specific location in the world. And then it can be a city that is linked to a certain latitude or longitude coordinate, or it can be any kind of data that is somehow related to a place on the Earth. And you might be thinking, I've never used GIS data, what is it? But I would like to say that probably all of you have used that kind of data, because it's the kind of data that's in the GPS system that you might use in your car. If you use your smartphone to look at a Google Maps or so, you are viewing geographical data as well. So I think everybody has been viewing and using this kind of data, but maybe not so many people have had their hands on the actual data that's behind those products that are quite common. And by getting access to that kind of data, as I will show later on in this presentation, you can do quite interesting things for Flight Simulator as well. So GIS data is data that is somehow related with a location on the world. And there are basically two categories of geographical data. One is called raster data, which is like imagery or elevation data, which you see here on the left. So that can be a satellite image of your town, or that can be a raster file that defines the elevation of a certain area, where each pixel of the image represents the altitude at that cell, at that position. So you basically see how the elevation changes over space. That's kind of raster data. And another kind of GIS data is vector data, which is more the data that is normally used to draw maps. So that's more data built up from lines and points and polygons. And I will talk a lot more about vector data in the rest of this presentation, because that's the kind of geographical data that's most interesting to create Autogen. And we will not cover raster data anymore, but I just wanted to let you know that that's also the kind of data that's available. But we will look at the vector data from now on. So like I said, vector data consists of polygons and lines and points, and that way it defines objects that can be found in the world. For example, a polygon might define where there's a forest, or might define the shape of a building, or maybe define in the town which part is the industrial zone and which part is the residential zone. Those kind of things can be represented by polygons. With lines, things that are more linear in shape are normally defined. A very obvious example of that is of course a road, but also a railroad or maybe the power line running through the landscape can very well be defined by lines. And point features are usually used to just mark a single point and say that there's a certain object there. For example, that it's the location of a church, or maybe there's a light pole over there, or a traffic light, those kind of features. And any of those three types of vector features can have additional attributes defined to them. So if you have the shape of a building, the attribute can be to say that this is a farm, or this is maybe an apartment block, or that kind of attributes. Or if you have a road, it can say this is a highway, or this is a small bicycle path, and what's the width of the road. So all that kind of additional data can be provided as attributes with the vector data. So that's all very interesting, but where would you get your vector data if you want to use it for Flight Simulator? That's not a very easy question to answer in general, because where to get that kind of data really differs from country to country. In general, it can be said that each country will have some national geographical office which has the official data of that country. That data is often used for the official maps that you can maybe buy at the government, or maybe also the military of the country sometimes use. But this data often is only available if you pay a lot of money. And there are also commercial companies that sell data, but then again, it often costs quite some money. And most Flight Simulator add-ons won't sell 100,000 of copies, so then the investment to buy data is usually too much for the turnover that an add-on will make. If you're living in the United States, or if you're making an add-on scenery in the United States, you're a bit more lucky, because in the United States, the United States Geographical Survey, the USGS, has made a lot of data available for free, which includes vector data as well. And their philosophy is that the data has been collected with taxpayers' money, and then it should be made available for free to those taxpayers afterwards as well. And then they made it available to the whole world, which is very nice of them. And more countries are following that approach. I know that, for example, in the Netherlands also more and more data is nowadays becoming available for free, but still not as much as in the United States. So where to get your data really depends on which country you live, what kind of data you want. If there's maybe some local organization that has it, there's no easy answer for it. But there's one other alternative, very interesting alternative, and that's the OpenStreetMap project. That's a project started in 2004, and the aim of that project is to create an open source map data. So to create sort of an open source map of the world. And the data in OpenStreetMap is in general collected by people like you and me, who go out with their GPS device and just track their local street, or maybe if they go cycling, they will take their GPS and track all the bicycle paths that they followed. And by collecting and combining all that data, slowly a map of the world emerges. And there are also companies who have donated data to this project. As you can understand probably, as it depends a lot on what people have collected and contributed, the quality of the data is not the same everywhere. Big parts of Western Europe have very good coverage with very detailed data, but in other countries you might find out that one city has quite good coverage, while another city has only the main roads and not all the other roads, because somebody hasn't traced them yet. So that's something to keep in mind when looking at this data, but at least for Western Europe it's very good data with a lot of features in there that's very useful for developing your Flight Simulator scenery. So what's the idea now? What if we could take some GIS data and then convert it into Autogen for Flight Simulator? So if we have GIS data that defines where the forest is, Wouldn't it be nice if that could be translated to an Autogen file that places forest at the same place? And the same for houses and for other kind of features. So that's the idea. And with that idea in mind, I started making a tool which I called scenProc, which stands for Scenery Processor, as it processes data to make scenery. And that tool can import GIS data, and then you define a number of rules how you want to transform that data into Autogen scenery for Flight Simulator. So what's the basic workflow of the scenProc tool? At the heart of the tool there's like an internal representation of the vector data, and as I just explained, that's made up of polygons, lines and points, which all have some additional attributes. And this data can be imported from a number of formats. One of them is the shapefile format, which is a very common format to provide vector data in. Another one is the OSM. It's a OpenStreetMap specific XML format, which is probably the best format to load your OpenStreetMap data from. KML is another format that can be imported, which means that you could use Google Earth to trace some polygons or some lines and then import them into the tool. And the last format is DXF, which is more from AutoCAD, which some people use, but I think the other three are more practical when making Autogen. And then on the other end of the tool, it can export to Autogen buildings, to vegetation and to library objects from those polygons, lines and points that you loaded from the GIS data. And because sometimes maybe the data that you load needs a little bit of manipulation before you can use it for the Autogen, the tool can also process the data. So it can add additional attributes to the data, maybe create new features with certain rules. But this is the typical workflow of the tool. I will give some examples of how the data can be processed, and after that we'll jump onto a demonstration of how it works, because that makes everything much more concrete. So adding new attributes. Let me just give a few examples of that. The first example is that you can add a new attribute to a feature by combining the attributes that are already there. And the picture here on the right shows the shapes, footprints of buildings, and you see that they have different colors. And those colors are defined by attributes, but I assigned those attributes myself. And for example, the red buildings, as you can probably see, are the more rectangular buildings. So that are buildings that only have 4 vertices, and I gave them an attribute to say that this is a simple building. The more purple buildings are almost rectangular, but they have maybe some small deviation from that. So based on other criteria, like the area of the polygon or maybe the amount of vertices, etc., I assigned different attributes to them. And I can then later on use those new attributes to easily create Autogen buildings from my footprints. Another example of adding new attributes is shown at the bottom. In the picture there you see a green polygon, which is a residential area, and a yellow polygon, which is an industrial area. And all the black shapes are the footprints of buildings. So then I can add a new attribute to all those buildings that tells them that they're either in the residential area or in the industrial area. And then later on I can use that attribute to give a different representation to the industrial buildings than the residential buildings. On this slide I have a few examples of processing that can be done to add new features to the vector data. And the first one is to place points along a line. So you might have a road, and then if you want to place light poles along that road, for example, you want to have point features defined at a regular distance along that line. So that's what this processing does. It places points along a line. Another kind of processing is to replace a complex polygon by rectangles, which is what you see on the middle picture. This is mainly useful for Flight Simulator 2004 vegetation. As you might remember, I mentioned that that kind of vegetation always has to be rectangular. So if you have a forest in a much more complex shape, you need to break it up into a set of rectangles, and that's exactly what this kind of processing can do. And the last kind of processing is replacing complex building footprints by a couple of rectangles. So as you see on the bottom picture, you might have building shapes that are not perfectly rectangular. Here it's more like a L-shaped or S-shaped building, but these could very well be represented by two rectangular buildings. So that's what this processing step does. And this is necessary because Flight Simulator only allows you to create rectangular buildings. So if you would take the original S-shaped building, for example, placing a building that would cover that footprint would result in a building that's much too big. I have to say that the processing to make those new rectangles, it works, as you see here on the picture, but the algorithm is not so robust yet, so it has a lot of weird results. I'm still working on that. So that's basically the kind of things you can do with this tool. And as you will probably understand by now, the tool is quite flexible. But on the other hand, that also means that it has some learning curve. To be able to use the tool yourself, you need to understand a bit what the structure is of the GIS data that you put in. So you need to understand what kind of attributes does my data have, what kind of features are in there. And also there's not a fancy graphical user interface for the tool. It's, like I mentioned before, it's more like a configuration file where you define rules to specify what should be done. So it can be said that this tool is maybe more for a bit more advanced users. So who's using this tool at the moment? Well, as far as I know, it's either other scenery developers who would like to add Autogen to the add-on they are working on. So then they use this tool. But there are also some, let's say, advanced users, people who are mainly flying Flight Simulator, but they've bought maybe a photo scenery without Autogen, and they want to make it nicer for themselves, and they add some Autogen for themselves. But they do it not to share it with others, but just for their own enjoyment and to make their own Flight Simulator nicer. So that has been a lot of talking about what the tool is, what GIS data is, how it can be used. But I think to illustrate it much better, I should just give you an example. And that's what we're going to do now. We'll take another island in the Netherlands, this time the island of Texel. It's another Wadden island. And we will create some Autogen for this island. And to keep it simple, I'll just create three types of Autogen here. I'll create forest based on polygons that define the forest. I'll create simple houses, and with simple I mean that I'll just take the footprints that have 4 vertices that are rectangular in shape. I will ignore the more complex shapes for now, and I'm going to place light poles along a road. And that's what I'm going to do in this demonstration. But before jumping to the demonstration, let's first jump to Flight Simulator, which I had running here in the background already. And here you can see the photo scenery that I will be using. Once again, it comes from the Netherlands 2000 project. And here you see the island of Texel, with a village you see here, a lot of holiday buildings. There's another village in the middle of town. There's some roads running around. So this is the area we will populate with Autogen. And I will close Flight Simulator now, and then we'll go ahead to create the Autogen. So what I did here is I downloaded data from OpenStreetMap for this island. And let's first have a look at that data. So I imported the data in a GIS tool. In this case it's the open source QGIS tool, but there are other tools available as well, of course. And let us just have a quick look at what kind of information is available in the OpenStreetMap data. So here you see the island again, and I've set it up to show different colors for different elements. Let's zoom in a little bit. The green polygons you see, they all have different shades of green. they define the land use of a certain piece of land. And as you can see, the darkest green is residential, which is here, one of the towns. Slightly lighter green, so maybe here at the edge, there's like industrial. The even lighter green ones are there's forest in there, which is obviously what we will use for our forest. But there's also farmland, there's cemetery, there's grass, so there's a lot of data in there. And let me just try if I can select one of them. Did I grab a forest? Yeah. So here you see it has an attribute that says land use, which is a value of forest, which indicates that this polygon is probably the more L-shaped one here in the middle, is a forest. So that's the attribute we will use later on to select this data. There's also building data in the OpenStreetMap data, which is sort of another layer, and it has an attribute building, and the possible values are yes, to just say it's a building. There's residential buildings and garage. Most of them are just building is yes. So these we will use later on to create our buildings. And then the third layer that I loaded here, and I should say there are even more than this in OpenStreetMap, is the road layer, or as it's called in OpenStreetMap, a highway. And that defines the roads, and you can see that there are different types of road. There's a cycleway, footway, a simple path, pedestrian, residential road, secondary road, track, unclassified road. And if we look here, you see probably there's this blue road running here. This is the ferry to the island. So this is sort of the main road on the island from the ferry to the main towns. And if we click on that road, I should first select the layer with the roads. If I click on that road, you see it has an attribute highway is secondary. So the secondary road is sort of the main road on the island. And we'll use that later on to place light poles along this secondary road. Okay, so that's the data. I'll close the attribute again. So then it's time to jump into the tool. And here I just started a clean copy of scenProc. And I will just create a new file. Call it FSconfernz, since this was the presentation for the Flight Simulator conference. And now I just have a clean and empty file. So what do we need to do? The first step we need to take is that we need to import the OpenStreetMap data. And this looks like a text editor. It basically is a text editor. Like I said, the configuration file is just text-based, but it has features like tooltips and auto-completion to help you know what you have to type, a bit like in a programming environment. So if I start to type import OSM, you see already that it suggests which different options are available. And once I press enter, it tells me which additional attributes I need to provide for this step, so for importing the data. I need a file name. It's Texel.osm. I can specify if I want only data within a certain latitude-longitude range, but I'll just ask it to import all the data, and I'll do the same here. You can select only import features from a certain layer, but I'll just take all the layers here. So then I have imported my data. Then the next thing I need to do is that I need to split the data so that it aligns with the grid that is used by Flight Simulator. As I explained on one of the earlier slides, the Flight Simulator world is divided in grids of 1 by 1 kilometer. So if I have data that doesn't know about this grid, I need to split it so that the polygons are clipped if they cross the border, lines are cut as well, etc. So for that there's the split grid step, and it can take as an attribute AGN, which is then automatically the size of the Autogen grid. Then you might remember that we wanted to place lights along the road. So there's a place points along line step for that. And then with filter I select the features along which I want to place my features, place my lights in this case. So I say highway is secondary, and I want to place them at 150 meters interval. They can have an offset. I'll give it an offset of 5 meters. If I don't do that, then they will be placed in the middle of the road, which will look funny for light poles. It would be quite dangerous for the traffic. And then I can add an extra attribute that I can use later on to identify those new points that I made. So I'll just say object is light, and the heading of the light will be stored in an attribute HDG. By the way, if I press the scan attributes button here, it will load my data, and then when I'm typing the filter or so, it will help me and suggest possible values, and you'll see that later on. So now we have imported the data, we've split the data, and we've created our new light points. Then it's time to create the Autogen. So the first thing we'll do is create Autogen polygonal vegetation. And then we'll use all objects that are land use is forest. And we want feature type is polygon, so we want all polygons that are forest, and those we need give a certain type of vegetation. That's defined by GUID, like a unique identifier, but there are configuration files with Flight Simulator that actually define what kind of trees are used in. And you could type that GUID, which is a 32 character hexadecimal number, but the auto suggestion of the scenProc will help you. So if I start typing the name of, sorry, shouldn't have pressed the space there, then it will give me a list of all suggestions. So for example, terrain Autogen class, I want mixed forest in this case. But you see there's also tropical forest in the list, or there are many other forest and fields, tree crops. There are many choices here, but I know mixed forest gives nice forest. It works well for the Netherlands. So that's my forest. Then I want to create my buildings. So I say create Autogen generic building. Here I want to take all polygons again, which have an attribute that says building is yes, and I will only take those that have 4 vertices. So feature number of vertices is 4. And then I need to define a roof as well. That is done with a GUID again, but I can say, let's say roof, and you see here there's roofs for flat roofs, but I'll take gabled roofs all as my GUID in this case. And then we still have to create the light objects. So then we do create Autogen library object, and for the filter I will then say feature type is not polygon, sorry, feature type is point, and object is light. For the object GUID I will take the urban street light, 8 by 8 meters. The heading attribute, so what the attribute that defines the heading of the object is HDG. I've defined that here in the place objects along line step, and I need to provide the length and the width of the object, which could be seen in the description here. And one thing, I didn't show that yet, but I should have probably done that in the beginning. If you hover with your mouse over the step, you'll get a help text that explains you what the different attributes are and what you can fill in and what it does. So with this, I've defined everything that should be done. Then the last thing that I have to be doing is to write my Autogen files. So I do write Autogen files. For the version I can choose between Flight Simulator 2004 and Flight Simulator FSX. I'll use FSX here. And I need to choose the folder where the Autogen should be placed. So for that I'll just quickly browse to the folder where I have the Netherlands 2000 scenery installed. But typically you would select the texture folder of your scenery there, where your photo scenery is located. And with this I have defined my workflow, my configuration for creating the Autogen. As you see, it's relatively simple. So now I'm just going to press run, and this will take a little while, and while it's running you see here's the progress bar. It's importing the data. Now it's splitting the data in the grid used by the train system. How long this processing takes depends a lot on how many data you load. If there's a lot of data to be processed, it obviously takes longer. And also how big the area is that's covered. If you have a huge area, for example, then splitting it into those 1 by 1 kilometer tiles will take much longer than if you have a smaller area. So for very big projects, it might actually take half an hour or an hour, or maybe even longer, to process all the data. The tool will use as many cores as it can find in your computer, so it has been optimized to make use of multiple cores and thereby do its work faster. But as you already see here, it can sometimes take some time. So then we just need a little bit of patience. But the progress and the you get along the way should tell you if it's still responding correctly or not. Well, you see it's now almost done with splitting the grid, which is probably the step that will take most time here. The other steps should be much quicker because they have to process less data. But let's just wait a few seconds until it's finished. And as you see, it's finished now. It gives you an overview of how much time it took to run. In the output, it also tells you that, for example, that the place points along line created 101 points, so 101 light poles in this case. It created 2,352 forests, 5,000 buildings, and those 101 light poles again. And there are 138 Autogen files created. So it gives you a little bit of background information. So now we'll have a look at how this all looks in Flight Simulator. So I'm going to start Flight Simulator again. When I just said that running scenProc took a little bit of time, well, I guess everybody here knows that loading Flight Simulator can also take quite a bit of time. So let me jump back to the presentation, and I will already explain to you the next slide, and then I'll come back to the result in Flight Simulator later on. We just had the demo. So to summarize this a bit, I just explained the basics of Autogen, and I think a lot more can be done with Autogen. Sort of the sky is the limit, I would say. Just a couple of ideas of things that you could still do with GIS data and with Autogen. Now I just created some buildings, but if you have additional attributes, you could have a different roof type for different buildings. For example, buildings in an industrial zone are much more likely to have a flat roof, while buildings in a residential zone probably have more a peaked roof or a gabled roof. So if you have attributes that tell you the kind of building, or if you can derive them yourself by checking if the building is inside an industrial area or not, you can create more realistic Autogen. The same for using data that tells you how population dense is an area. If an area is very population dense, it's more likely to have tall skyscrapers. So then you could adjust the height distribution in the Autogen tile to have more big buildings in the areas where population density is higher. Or why not make a vegetation class, a custom vegetation class, and fill it with cows and use them to populate the fields. Instead of placing trees, you could be placing cows in the field. I think the yeah, the possibilities are, well, almost endless, as long as you have good ideas, and if yeah, just try it out and have fun with Autogen. I think it's a very interesting technique, and in general it gives quite good performance as well, and it can really make your photo scenery much more realistic. And I said before that the sky is the limit. I should probably change that. I should probably say that the quality of your data is the limit, because the better GIS vector data you can find, the more interesting things you can do. If you have data that has a lot of features in there, a lot of good attributes in there, it's much easier to create Autogen. But if you have data that's quite sparse with very few details, then the task will be much harder, unfortunately. So let me jump back to Flight Simulator, and as you can see, it has loaded now. And where we had a completely empty island before with no Autogen objects at all, you now see that there's forest here along the dunes. In my little town over here, we suddenly have houses being placed. As you also see, not the entire village is filled, which is because I only took the very simple footprints. I only took the footprints with 4 vertices now, and those other houses are apparently more complex in shape, so I need to do more processing to turn them into Autogen as well. I showed some of the additional processing that can be done for that, but yeah, for the time of the demonstration I don't include it now. And you'll probably remember we have one more object to show. Let me orient myself. We need to find the light poles, and I think this is the main road of the island. There they are already. Here you see the light poles along my road, and I will load a little bit, or I'll wait a little bit for the photo scenery to complete loading. And you see, as the higher resolution road appears, you see that they're nicely placed along the edge of the road. No, it's still loading. It seems a bit slow with the video capturing program also running, whilst probably fighting for the CPU power. But you see that the light poles are nicely placed along this road. They follow the curve in the road. Well, here they get a little bit in the middle of my road, but in general it gives very nice results. So that's a quick demonstration of creating Autogen on a piece of photo scenery from GIS data. Yeah, if you have questions, please go to the FS Developer forum, which has a subforum to discuss the scenProc tool. Any information, including a link to that forum, can be found on my website, the scenerydesign.org website /scenProc, which gives you all the information about this tool. So I hope this presentation gave you an idea of how Autogen could be created and how geographical data can be used for it, and maybe that it inspired a few developers to enhance their scenery even further. So thank you for watching, and once again, if you have questions, feel free to post them on the forum.